Alright, so in this video we're going to discuss an electric dipole example problem. So we have charge 1 and charge 2. And this is a dipole, so one's going to be positive, one's going to be negative, and we're going to have plus 4 nanocoulombs and then a negative 4 nanocoulombs. And they're separated by a distance of 2 millimeters. Alright, and it's in a uniform electric field with a strength of 50 nanocoulombs, and that is parallel to electric dipole moment. So remember, the electric dipole moment is in the same direction as D, so the distance between the two charges. So that means the electric field is pointed along here. So that's our uniform electric field. So we want to know what the torque exerted on the dipole is. So we know torque is equal to the electric dipole moment, so Q times D, times the electric field strength times the sine of phi, where phi is the angle between the electric field and the dipole moment, or the distance d. So I plugged in the charge here, 4 times 10 to the minus 9 coulombs, the distance between the two charges, so 2 to the minus 3 meters, so there are 2 millimeters, times our electric field strength of 50 newtons per coulomb, and then the sine of phi, where phi, since this is distance d, and the electric field is supposed to be parallel to that, my angle is 0. So the torque actually being exerted on this dipole by this electric field is 0 newtons times meters. So in this case, you do get a torque that is 0, and it would not be rotating at this particular point.